Time to switch to English, and we have a special guest today, Roy from Tel Aviv. Give us a second to switch laptops.
Can you hear me? Yeah.
Yeah.
I hear the echo. So. Cool. Just there you go. The other side. Oh, no? No. No, you did good. For some reason I thought it was. There it is. Oh, thank you. Good. Oh, thank you.
Запоминайте вопросы, у нас есть, как обычно, подарки.
Cool. So, can everybody hear me? You people over there, people over there. Okay. Hello, welcome to Security and Privacy, the real Slim Shady. I gave that name because I couldn't think of a better one. It doesn't mean anything. So let's talk about why is it not going away? Go away. There you go. So let's talk a little bit about what, why, who, and whatever. Introduction. Why should you listen to me? Who am I? So I have been an Android developer since 2009. I have been a very active tech activist, mostly in Israel, but also internationally. I spoke at Google I/O 2 years ago. I spoke at a bunch of JoyCons, Code Motions internationally, Mobius Conf in St. Petersburg and Moscow, et cetera. I'm a mentor at pretty much everything that calls itself an accelerator in the state of Israel, which a lot of accelerators in Israel. I've been part of the Google Experts program since December 2012. I tend to say that I'm the first one simply because I couldn't find anyone who says they were an expert before December 2012, but that's not an official thing. I am the ecosystem relationship manager at something called Samsung Next in Tel Aviv, and I'm also an investor there, which tells you that it's a VC or a fund that invents startups. Just so you'd understand and know if I have a hidden agenda or something, I'm going to talk a little bit. So Samsung Next is an innovation arm. It's an American subsidiary to Samsung Electronics that has nothing to do with mobile development. We do investments in startups. We do some product creation, mostly in decentralized compute and AI development tools. And we do a bunch of other stuff for Samsung Electronics and Samsung Next. But it is also giving me the opportunity to do a little bit more research from within Samsung Electronics to mobile and Android security, which is my forte. It's also what I focus in investments, and it also was my expertise in development before I went on retirement. So I talked to two very prominent people. One of them is the head of cyber research in Samsung Research America, which most of the cyber development is done there. And the second one is the head of the chief, the CISO for Samsung Electronics. With them, I managed to increase my understanding of that field. I also have, like I said, I focus on cybersecurity investments. So these are my portfolio companies. All of them are in that field. All of them provided information, case studies for this session to make sure that it's current and fresh and everything else. So let's talk a little bit about what exactly are we going to talk about. Users, more so in the last couple of years, are very concerned with privacy and their data security. The problem is that malware apps do exist, a lot of them in Google Play, and that most users have absolutely no idea what is safe and what is not. So they tend to pick on the trivial and they tend to ignore the not trivial. And in some cases, they simply have no idea and they don't know what to do. So what's the premise of what I'm going to talk about? What can you do here? So let's assume that users exist. hopefully, or in theory for most of you. How many people here actually have apps in production that have users? Okay, that's good. You want users to trust you, at least I assume you do. And you want users to be safe, at least I hope so, or in theory. And I'm absolutely sure that all of you want your intellectual property, the stuff that you've been working on, to be safe from being copied or stolen or misused. So I put it as absolutely, unless there's some masochist in here, which brings a conflict that most of you, I'm looking at your faces, I don't think you understand the conflict, so I'm going to go into that. By the way, if I'm going too fast or you can't understand what I'm saying, just tell me, okay? So users want a personalized experience. They tend to react to it better. When you solve a need for them without them having to ask for it, they usually rate your app a lot better. They usually use your app a lot better. That's according to surveys and common sense. Developers, in order to get that personalized experience, need to understand the person in front of them. So they need access to a certain amount of information. But as we mentioned before, hackers do exist. And hackers also prey on this amount of information to either benefit from the actual user's data, to cheat them or to steal it or to sell it or something, or they benefit from your work by trying to steal your apps or your API services or your tokens or whatever it is. So there's a conflict between the amount of information that you want to have and you still want it to be as minimal as possible so you cannot incur damage, cannot create damage for the users if something happens. So the first thing I'm going to start with is not necessarily about actual privacy or security. It's more on the area of how you make users trust you more or how you avoid the traps. One of the biggest traps is permissions. How many people in here have seen either on their app or a different app someone commenting somewhere on why would this application need access to my call log or to my text messages, or thinking they're going to steal something? Or so these apps do exist, but in most cases, or in let's not say most, because I don't know if it's most cases, but in some cases there's an actual legitimate use for permissions that you don't have a choice. So up to, just a quick reminder for those of you who are completely in the dark, up until Android 6.0, all permissions were requested on the Play Store. You got a list of permissions. That's how it is. Most people just click through because they didn't know any better, and that's it. After 6.0, things changed. There was so much turmoil. People say, I don't understand why this app needs this or why this app needs that. So Android says, cool. So some basic apps permissions are at the beginning because it's understandable or it's basic or something else. But others should be requested in context, meaning that the user will have a better understanding of why he or she are being asked to provide a permission. And if the permission is denied, either on the spot or after the fact, the application needs to respond gracefully or fail gracefully. So how did that play out? Google, in the last Google I/O, actually released a survey of some 60,000 applications and their reviews, asking regarding how many permissions were revoked, and why. And the stats are kind of funny, at least to me. So the top 3 reasons users told Google that they denied a permission from an application is, and I quote, apps should not have the permission, meaning that the user thinks that the developer is either an idiot or they're trying to steal something, which is, at least to me, that's funny. The second thing that they quoted was apps should still work without the permission. That means that the user thinks that they know more about how applications work than the actual developers. Again, I think it's funny. The second thing is that I can always grant permissions later. Now, this is not that funny. This actually states something pretty obvious. It states the user does not understand why they are asked for the permission right now. That's a UX issue. That's a UX issue that's easy to explain if there's a legitimate use for it. So let's go on and talk about the 3 reasons that users allowed a permission. The first thing is that the users understood that there's a need for a specific feature that requires the permission. The second thing is that they trust the developer. In most of these cases, the trust is because the application was from a massive company. So it's not really a trust, but the fact that they provided a service that you got and you couldn't get anywhere else. But Google said trust because a lot of the applications were Google applications, so we'll leave it at that. And the third thing is that they feared that the application that they need and want would not work without the permission. Those 3 are the exact polar picture. It means that the user understands why they were asked right now, and or they trust the developers a little bit more. So what does that give us? One more statistic before that. 92% of all users asked denied at least one permission. 92, that means, no disrespect, but that means my 70-year-old mother denied permissions for applications. My 11-year-old niece denied permissions for applications. That means that nobody's safe. It means that we as developers should really pay attention to what we're asking and why, and if we actually need to ask for that permission, or are we just lazy? And that's the first thing that I'm going to do. I'm going to say, sometimes you do not need to ask for a permission. There is an easier way, or at least a way that does not make you ask for a permission. And I'm going to provide a few examples. So we'll play good idea, bad idea, which is something that came from a cartoon that was good when I was a teenager, but most of you seem too young to even remember Animaniacs, so we'll do it anyway. A lot of applications use SMS account verification. That is the recommendation for security and reduce friction in user passwords and a bunch of other stuff. It's also called multi-factor authentication. The implementation, the common implementation that exists still in most blogs, in most articles, requires you to ask for an SMS read permission. Now, when a user that doesn't know what that means gets the details of what that permission could give the developer, it says access to all text messages. They can read, and sometimes I don't remember which API versions, it also says send text messages. Said, why? Well, you know why. You know that you want that feature, that wonderful feature that the user does not have to click on the text message to leave your app, to find the number, to come back. You want to read it for them, right? That's a nice feature. But if the user is afraid that you're going to read their text messages with their lovers, or I have no idea, nobody uses text messages anymore. Everybody uses WhatsApp or Telegram, but I don't know. So you can avoid that by an example, because there are other APIs that are not Google's, but that's an easy example for me. There's an API in Google Play Services called SMS Retriever. And usage of it is very, very, very easy if all of your clients have Android devices with Google Play Services. And I know that in Russia, that's not necessarily the case, but nonetheless. So you get the client from what's now called as not Launchpad, Jetpack. You get the SMS Retriever client, and then you start a retriever. And a retriever has a listener that gets you everything that you need, but that does not get you access to anything else. So you do not need to ask for that permission. And the way that it does that is the same principle for all the other examples. You're actually delegating your request to an application that has the permission, usually a Google application. And because Google usually trusts themselves, and only themselves, then it works. Another example, if you have an application that has video or audio or something, when someone gets a phone call, you want to stop that gracefully, because some companies that manufacture phones, one of which pays for my salary, does not necessarily develop the player in the way that it should. So if you do not do that, something might crash. So a lot of people ask for read or write phone state permission, which again, in the details is very scary. Conduct phone calls. See call log. That is very scary for a company that you do not know, and it is extremely scary for specific companies that you do know, like Facebook. But, no offense if anybody here is from Facebook. I really like Facebook. I spend most of my time there. But you could use something like audio focus, which again exists because you delegate it to a Google app. You're saying, in Audio Manager Compat, which is now called something else or will be in the new Jetpack, stay tuned, you request audio focus. And then the minute you have audio focus, there's a listener telling you, do something. And then you can do exactly the same thing. Same thing goes for accessing contacts, which is a scary stuff. So here it's even easier. You have an implicit intent. You set the type for the intent. You want to insert or edit or something to a contact, and then you just start the activity. Now, this if actually asks the system, does this phone have some sort of contacts application? And I don't know a phone that doesn't, but if it's a tablet, it might not have. It doesn't matter. But it's asking, and if so, it opens another activity. The problem is that in these sort of things, you do not control the UI completely, so sometimes it will be annoying, but at least you don't have to ask for the permission, or at least you can think about that. Last example, because there are a lot of them, but I just wanted to cover a lot of bases, is the action video or action image capture, which removes the necessity to ask for permissions to access media. And here you simply ask in the manifest if the device that is installed has a camera. And then you just have the implicit intent. And if there is a camera app, which should be if the device has a camera, then you use that. Simple. Again, UI is not designable, is not updatable, because you trust it with a different app that has the permission. But again, you have to weigh pros and cons. If we're on the subject of permissions, and again, this is not specifically on security and privacy, but I think it's important because I didn't mention it, but part of what I did for the Google Experts program was to be one of the reviewers for Google Play of applications. And I saw a lot of horseplay, to be mild. So developers that didn't understand the concept of contextual permissions simply dumped all the permissions in some screen, and then they got terrible ratings and they couldn't understand why. So don't do that. Instead, allow when it makes sense. For this is a chat app. Now the chat app, if it would request beforehand permissions to record videos and take audio, you're saying, no, I don't think I want that. But in this conversation, after you click the camera icon, then the permission makes sense, unless the user is an actual idiot. But in most cases, it will make sense. So if I do want to take a picture, I will allow this. And the conversion rate, this is I think it's, I don't remember what example is, but it's a very known chat application. And the conversion rate for allowing camera access increased from less than 20% to over 90%, simply because they're doing this, which should be self-evident for most people, but Second thing is a lot funnier. This is the Nest app, the app for the company that Google bought that does like smart thermostats or stuff. So they had a feature where they wanted to get into the information that tells you if the device that you're using to control the thermostat is in the house. So they wanted really strange sounding permissions like location and Wi-Fi data access and a bunch of other stuff. Nobody gave it to them because why would you want, I don't want people to know what I'm doing. It's a thermostat app. I want to turn it on and see if I have hot water. So they added this text and they had to learn more. They basically said, look, this is why we need it. And if you want to, we'll explain exactly what's the premise behind it. Here's the funny thing. Conversion went from under 5% to over 60. The number of people who clicked learn more is less than 0.5%. So they didn't really want to read it, but they said, oh, they have a reason. They wrote something, so it must be okay. And that is important. That is a good insight for most of you. If you have something that sounds strange, all you have to do is hire someone to write some bullshit, excuse me, and people will let you have what you want. Okay, so now let's go to actual security after we talk a little bit about user experience, gaining trust, and a bunch of stuff. And let's talk about data and your information and how you can start protecting it. Starting with communication. Any questions thus far? Okay. IPC is a nickname or a shorthand for inter-process communication. That tells you a lot, right? No, it doesn't. It doesn't mean anything. So it's the basic concept of where you have an entity, like an activity, and you have something that's unrelated to the process, like a database, and you're using a third tool that does not live in this process, but has to access this, which is processless, so it has to use a different process. That's why it's inter-process communication, because you'll have to communicate between this and that, and these are in different processes. Now, that sounds pretty simple, and it works well for a lot of asynchronous tasks like databases, like services, like home screen widgets, everything that's outside of the application, or it can be used for if you have a resource that you want to service multiple applications, which is something most people don't do, but that was the intention. That's why Android developed it to begin with, to use internally. The problem that this is a backdoor. Backdoor is a term in cybersecurity, in case you don't know, where something is installed for a specific purpose, but it can be very easily be used to do something very different, usually to do something that you're not supposed to do, like steal information. I'm going to talk about it. So what are the possible harms in leaks in inter-process communications? So the first thing is someone actually doing something bad against you, like screwing up your service because they don't like you. I don't know why. So here's an example, a real live example of a company whose name I cannot say, but I promise you that it's real. So this was in their code. It was a taxi app. And that taxi app had an application for the drivers, separate from the ones for the clients. And in that app, on the tablet, there was this code saying it's a receiver, a broadcast receiver. And if you got HTTP unauthorized, which is an implicit intent, so anybody can listen to it, we're going to go through it then, log out. Now, they had a reason for that. Some reason. I have no idea what reason, but one of their competitors found out. And that competitors started sending unauthorized all the time. So their drivers got logged out for a denial of service that cost them a lot of money. I don't know. I have no idea how much they're making, but a lot of money. And that's someone doing something purposefully because they know your vulnerability and they're doing something actively to hurt you. Second thing, I really wanted to bring an example. I had a few, but I couldn't get approval from the companies to actually show them. So I'm going to explain what it could be in general sense. Service piggybacking is, let's say that you are using a service that costs a lot of money, an API service. You get automatic, real-time information on the statistics of the next Taylor Swift tour. I don't know, something that costs a lot of money. So you pay per API call. And someone finds out that you're using this API, and because you do not protect yourselves, they take the token from your code with reverse engineering or man in the middle or a bunch of other stuff, and they start using your quotas. So you pay to build their service. That's called piggybacking. Third thing is a data leak, whereas you leave yourself open for people to steal the information that you need for your service, but they do it because they want to trade the data. And I have a very nice example. One of the first smart routers that came into the market had a companion app. And that companion app, to help teach the router about the situation of the network, had this or similar service where they set an explicit intent this time, and when it existed, they would take all the information of all the networks that the device was connected to, including the local IP, the port number, the code to access, the password for the router, if you are connected right now, the predefined password in case you want to reconfigure, et cetera, et cetera, et cetera, and then they sent it in broadcast. They thought, who cares? So a hacker found out, and he started polling all of the devices that had this app, and it aggregated the Wi-Fi information. Now, one thing that's fun, when you know exactly which networks a person has been connected to, you can pinpoint their location amazingly, and if you gain access to the actual password for the router, you can create a very, very vicious attack that actually locked people out of their routers in Chicago, or something. They hacked through 50,000 routers or something, or 10,000 or 100,000, I don't remember, based on the information in this app. That company that created the router doesn't exist anymore. Imagine why. So, one last thing is actually reverse engineering of your application. You may or may not know, but there are a lot of people, specifically in some countries, that take your apps, reverse engineer them, open them up, and take whatever they can, either how to access your API, or taking API quotas from services you use, or simply copy screens and change the in-app billing information. So they upload it again, a copy app of your applications, and they benefit from your work. So that also exists, but that's a little bit in the middle between communication and assets. So let's start talking about what is the most vulnerable thing and how to fix it. Intents. Intents are the basic building block in Android to start something outside of the scope of where you're in. Used for activities, services, broadcast receivers, etc. There is something called an implicit app. Implicit, as its name suggests, is when you explicitly call someone, when you know someone's name, like Alexander, you're talking to a specific person. It doesn't matter what you're asking for because you know that guy, you're approaching that guy. But if you'll say something like, I want a popsicle, it's a very implicit thing. Any number of people can say, hey, I got a popsicle, or what the fuck, why are you screaming, I want a popsicle out loud? But anybody can answer. I don't need to know that person for them to say, oh, I can supply that service. That's implicit. Your application is asking for a service, and any number of applications can say, I can provide that service. Do you want me to provide that service? That's implicit. And it's very easy. You put it in the manifest or in code, and you're basically using a catch-all kind of intent that other applications can sign up for. So it can be called by any app. No affiliation with your app is needed, and there's a problem there, because when you don't know who's responding, then you don't know who you're going to get service from. Someone that you want to get service, or someone you can't trust. And if you choose the wrong way, it could be bad. So it got so bad that it actually changed the permission state within Android in Android 5.0 for bound services. So how many people here have ever used bound services? How many people know what bound services are? Okay, fair enough. Bound service is where you have a service that has no UI of its own, and it's bound within the process to a specific app. So it is feeding a specific screen. So if you are connected to the wrong one, nobody would know. And so if the activity says, I need help, so it's searching for anything that hasn't dealt help, and you have a couple of those. So the wrong one can say, I'll do it. And then your application for sports scores can get information from a troll that's giving them, I don't know, information about My Little Pony. I have no idea. But it got so bad that Android actually changed. As of Android 5, it sends an exception when you do that. But again, I know a lot of developers still support legacy devices. So if you also support Android devices before 5.0, you need to check that you don't have bound services, or you need to do other stuff that I'm going to mention soon. So implicit intents, you could do that, but I don't advise you to. Explicit intents, as I pointed out, means that you know a specific name. You're calling, hey, I need your help with something. Then it's a lot easier. You need to have access to the scope of the activity. So in this example, the manifest has two activities, A and B. They're in the same scope because they're in the same application. And then inside an activity, you got access to this scope, and then you start an activity. That sounds kind of secure, right? You have control of the scope. The problem is that with reflection, that we're going to talk about later on, you can actually gain access to that scope from the outside. So it's not as secure as you want it to be, but it's a lot more secure than implicit. A lot of blogs in the last 3 years, 5 years, whatever it is, claim that intent filters are security features, because if you do not have the payload of data that I need, then it will crash. But that's not true, because we have an example of how you can do something that does not support it, which is this one. All you have to do is iterate over the device and find a culprit, because that's what they did. It's not really an intent filter, but their premise was that if I do not have all the extras, then it will crash through. But it only took one hacker to crash them down. So intent filters are not, I repeat, are not a security feature and should not be used as one. But there are security features that you can use. So, for an example, export. Export, by default, is false in Android. That is true. Export means that for intent-invoked purposes, like broadcast receivers, like services, if export is false, nobody from the outside of your application can access it. Sounds kind of secure. It's also default false, right? The problem is that in a lot of applications, the developers, especially in older applications, the developers didn't really know what they're doing. They're doing brute force. So they tried a bunch of stuff, and then at some point, one of the developers changed exported to true, and it worked. So they say, it's working, I don't care. And they created a massive backdoor into your application. So I urge all of you to go back to your code and see if there's somewhere where exported is true, change it to false, and see what happens. One other tidbit is that despite the fact that the documentation within Android says that export is false by default, few tests that I ran on specific devices and specific API levels over the years show that it's not 100% true. So in any case, because it doesn't hurt you, I would urge you to put export false anyway, because it doesn't hurt you, and if the person happens to fall on a device where there's a glitch and it doesn't happen, then you're not open for an attack. So that's what I said, Android exported manifest false. Last thing, or the most secure things in Intents is permissions. You're not just asking for permissions, you can actually create permissions. Now, in most cases, in all cases, is that if you have a resource that you can externalize, but you want to control who uses it, you can do it. In 99% of the situation, it doesn't make any sense. So there are 3 protection levels that I'm not going to talk about because I don't think you'll ever use it, ever. But there was one that makes sense. It's called signature. Signature means that the user does not have to approve anything. There's no new permission to approve because it doesn't concern them. It's not a resource of the device. The permission is granted automatically if the applications are signed by the same developer. That means that if you want to, you can have multiple applications and still only limit to applications you created because they're signed with your developer keys. And it's very easy to create. In the manifest of the resource, you create this thing, you give it a name, you say signature, and in all the other applications, you just put user's permission with that name, and if the application is signed with the same developer key as this one, you will be granted the permission, but only you. So nobody else can actually do anything. So that is far more secure. The last thing in this topic, specifically for broadcast receivers, is something called local broadcast receivers. Because broadcast receivers is such a backdoor and it's kind of hard to keep track, Google actually created this. It's the same as broadcast receivers, but it only works within the scope of your application no matter what happens. Not reflection, nothing else can access it except for your applications, not developer key, not nothing. So it's impossible for applications to use it, even if they detect exactly what you're doing, even if they reverse engineer everything. There's another added benefit, which is kind of small, but I just want to mention it. It's more efficient. The lag from sending to receiving broadcast receiver is 1/10 of the normal one, but nobody uses local broadcast receivers because of this, just FYI. And the usage is very similar to what you know. You have a local broadcast manager, you do a send broadcast, again, very similar. You have an on-receive, exactly the same, and you get the same information. You can unregister in the same way. So the usage is exactly the same, except for the fact that somewhere along the line, you add local to the name of the entity. That's it. So think about using it, at least you know it exists. Now, if we're on the subject of intents, let's talk a little bit about updates that have happened in the last API levels and why they happen. So as of Android 9, the network state changed action does not provide the location of the Wi-Fi, and it does not provide the personal information involved to it, i.e. the example we saw in the beginning, basically based on the same breach, because Google with that action actually gave the information if you knew exactly what you were asking for, so they changed that from Android 9. Wi-Fi read or write also does not get the name of the network, which is again another tool that was used to hack locations of people and gather information. If you do need that information for some reason, and there are legitimate reasons, in runtime you can ask for get connection info, and you'll get that information, but it will only live in the context of an app that's on the screen. It's a foreground app. Android 8, going back, changed implicit intents, where you can only register them in the manifest and not in real time. That way they could monitor what an application is registering, so when they upload it to Google Play, some of the automatic tests actually flagged apps that saw that they're trying to attack other apps. And Android 7 was a big change. Action New Picture, which was the chosen way for you to know if somewhere on the device someone snapped a picture of something. Same thing for new video. Both of them didn't work. And connectivity action, which was the premier way to know if the Wi-Fi situation changed or you got connected or disconnected, only works when the application is in runtime. The reasons for these is not security or privacy. It's because everybody registered those intents. So when someone snapped a picture, every app on the device got woken up, loaded to the CPU, because that's what broadcast receivers do. So what happened was a landslide. The CPU got overrun because you're waking up all these apps, and then you don't have enough memory, so you're killing some of the apps, and then you're waking up different apps. And it messed up the device, and it destroyed battery usage, especially at night. That's the same time they released the standby modes and the doze mode for that exact usage, because they wanted to conserve battery and reduce the amount of CPU uploading that was done unnecessarily. Moving on to files and storages. Any questions thus far? Either I'm very interesting, or you have no idea what I want.
Ребят, не стесняйтесь, задавайте вопросы, можно на русском. Any questions, guys? Folks? Oh, yes.
Я задаю, да? Но я только на русском, в общем, да. Спасибо за...
Давай, на русском.
Спасибо за доклад, очень интересно послушать было. Значит, я не совсем понял, там тема началась с Inter-Process Communication, а Local Broadcast Receiver, менеджер, что-то не совсем понял, он как к IPC относится вообще, он же не работает между процессами. Как бы. Хотелось бы какие-то решения именно для взаимодействия между процессами услышать. Вот. Сможете сформулировать? Да?
Okay, so the first part was thank you for this talk. The next one was about how IPC connected with local broadcasts, or it doesn't even much.
So technically, local broadcast is a form of IPC that doesn't work between processes, which is stupid. But the point I was trying to make is that a lot of people used IPC without them needing IPC as a convenient tool, and in the process, no pun intended, they created a backdoor that harmed them. So local broadcast is actually giving you what you wanted without the harm.
Hi, my name is Arthur. I work in a company that basically develops an app for video ringtones and for caller ID. So we work with calls, we work with SMS, with all this stuff. Mm-hmm. And we, on the contrary, found that for us, it was better when we had a screen almost like immediate after onboarding, just like, oh, okay, you will see video, you will see caller ID, please give us like all the permissions, especially for the old versions. Because yes, around like 10% or so users just like, oh, I want to do this. However, all the users who already gave this permissions, they were kind of, oh, okay, I already gave it, so let's look what it can do and what's basically will happen further. So yeah, do you know about any research like this? In which cases it's better to have all the permissions kind of on start instead of getting them in context and all of these cases? Because yeah, as I know, Wikium or maybe Clevermind, some app basically did a research that if you are making a long onboarding, yes, you will lose like people on every stage of the app. From the other hand, like the people who already passed the onboarding, they will feel better kind of to the app, and they will retain better in like 7 week, 30 week days. I mean, 7 days, 30 days retention, right?
So there's a lot of research on that. It is not as conclusive. You just pinpointed to specific use cases. Now it depends on many different things. For instance, the profile of your users. Are they, if they're more interested or they're more keen on getting your product because they really need it, they think it's cool, like a video ringtone is something that it sounds like a cool thing that people will do, like I know teenagers, so they don't care. They're not even thinking about that. Most of them take pictures of themselves and their food 15 times a day, so they simply don't care. So for them, a long onboarding would be just give me what I want. I really don't care. So persona identification is extremely important. I don't have specific data, but if your data or if data like you identifies that you're doing something that's right and it does not work well for the rest of the applications, do it. As long as you thought about it. And you can do A/B testing. But because each and every app has a different audience with different needs, the research, there's a lot of it, changes every time.
Okay, cool, thanks.
Sure.
Hello, my name is Nikolai. I have one question. Currently, my stack is Ionic application. It is have three providers for works with file system. It is security storage, local storage, and Ionic storage. What I must use for security and needly specific permissions by Android. For example, we have login and password, and we want save it. For example, if I have to successful authorizated.
So you're asking how you're going to secure
as cookies
like
for
personal information on the
yeah.
device? That's exactly the next segment.
Okay.
Okay. And encryption after that and after that. So hopefully I'm going to answer the question.
Sorry, and it is encryption is possible. For example, we support older Androids. For example,
Right.
Android 4, 3, 2. It's possible.
Jetpack takes it there are multiple levels of encryption.
Only last version.
No, not last. Jetpack brings it to API level 21, which is still kind of new. Encryption is supported all the way to API level 1, but it is not the most sophisticated one. It will still work, but it will still be easier to hack, so it's a give and take.
Yep. For example, files what will deleted by wipe and ATK.
The what? What was the question?
Files can be deleted by wipe.
Yeah.
Okay.
Cool. So,
One more question
Oh.
here.
Hello. So you said that some firmwares did not set exported to false by default.
it seems so by the test that I did.
Okay. So what if some China vendor with relatively decent customer base would roll out an update which completely ignores exported?
So, it will be either I didn't understand the question or you're asking if there's some way for someone to force export false on devices?
No, if the vendor itself would release an update with which ignores exported.
Could happen. It's a bug. If it happens,
Yeah,
it is possible.
and then it could steal its users' information.
Technically, that's possible. It is very unlikely because of the CTS test suite that OEMs and ODMs are obligated to go through. It doesn't mean that it cannot happen, but it is very improbable.
And what is CTS?
Hmm?
CTS.
CTS, when you manufacture firmware, like validated firmware that Google approves, then you have to go through a list of tests of the firmware, the application layer, and the kernel level. It is called CTS, or compatibility testing suite. You'd not know that unless you're a manufacturer of devices, which I was.
I see. Thanks.
Sure. Okay. So, encryption 101. Let's take an example. Let's look at this diary not mine. I have a far more manly diary. And it keeps what's written inside in a way that people with the key can read it. And people without keys do not have access to it, like my wife. And I can distribute the keys if I want to for other people to enjoy this diary. So in cyberspeak, in terms of cryptography, the diary encrypts secrets using a key. Now, the same key is used to lock and unlock the diary, which makes sense because that's how physical locks actually work. In cybersecurity, this means that the diary uses symmetrical encryption because the same key is used to decrypt and encrypt a secret. So if you have access to this key, the one key, you have access to all the secret it ever encrypted, which could be dangerous. That's why symmetrical keys are usually for custodial assets, things that you can own and are hard to duplicate. But that is not always the case. That's like communications. SSL HTTPS, the secure communications client and server, does not use symmetrical key because that doesn't make any sense. They use something called public-private key pairs, which means that there are two keys that are different from each other in size and in composition, et cetera, but there is a function that tells you that they are a pair, that they are together. And if you put one public key and one private key that are the same length but are not created together, they would not match. So different keys can be validated with each other. What's encrypted with the public key cannot be decrypted with the public key. It has to use the relevant private key to decrypt. And if you encrypt with the private key, then you're doing something completely different. Nobody does that. You could do that, but it doesn't make any sense. So the point is that you can give away the public key to anybody. They can encrypt secrets that only you can read, because only you have the private key, and that's important. So let's give an example of Bob and Alice. This is Bob and this is Alice, because that's the world we're living in right now, where you cannot assume people's gender and stuff. So, Bob, I want to send the sensitive data to Alice, but I want to be sure that only Alice may be able to read it. I will encrypt data with Alice's public key. Notice that this is a conversation that all of you had once in your life. Very reasonable conversation. Since only she has access to the private key, only she can read it. So the information is sent, and then we're getting to not Alice, which says, hey, an encrypted message from Bob. I'll try Alice's public key. It doesn't work. I'll try my private key. Nope. Okay, I don't have anything to do. Sorry, I have a little girl, so I've been reading stories, so it's in my hand. Sorry, I had to. So that's the situation that explains private and public keys better. And let's talk a little bit about terms. They're not really important terms, but if you want to Google it later to see exactly how to work with, you'll need to understand what it means, because those terms are not explained anywhere, and it's very annoying. So I'm going to try and explain to them. A master key is, I don't know how it is in public schools in Russia, but you probably had a custodian or a janitor that walks around with a bunch of keys to open everything else. And then what happens is that one day he got very angry and he ditched all of them and he had one that opens everything else. That's a master key. It's a key that opens everything else. In this case, it's kind of different because the master key is not used to open everything. It is used to create separate keys that encrypts individual secrets in a way that the master key can still deduce the encrypted information, but those keys that were created cannot actually be used to decrypt secrets from other keys created from that master key. It's kind of a complex explanation, so I'm going to try again. Master key is creating the key that encrypts other secrets. So if you have API keys for a service for the server that you use in the application that your backend people develop, so you would use the master key to create the key that will secure the API keys. Now another app on the device will do the same thing, but that does not mean that if a hacker gets one of the keys that were created, they can open up your secret. They can only open the secrets for the public key that they have, the application that they have. Did that make any more sense? Okay, we'll go through it and we'll see if I can do it better. So API keys, tokens that give you access to databases and services, username passwords for your users that you want to secure in a way that makes sense. Those are all secrets that you can secure. Alias is the human readable name in which you identify, because there is a key store on the Android device. It's actually called the Android key store. And for you to access your key, you need two things. You need to be yourself, meaning the application that calls the key is with a certain package signed by a certain developer key, and it has to know the human readable name of the key that they're using. That's why it's to increase the amount of things that a hacker would need to know to take away your key. So it's called an alias. So you can get it from the device stick, known as the Android key store system. Hash functions, like SHA and MD5. Most people, when you ask them about encryption, they will say, oh, I'm using SHA-256. But that's wrong. That is not an encryption, that's a hash function. What's the difference? An encryption is something that you encrypt a secret, but you can decrypt it to the original state. Hash function is not used that way. A hash function take text and it changes it into something else. That something else never if someone gets that something else, they can never go back to the original stuff. So why are these used? Because let's say you don't want to secure the username password of your users on the device, but you want to still know that they are the same that you have on the server. So you'll hash it on the device, so it's hashed on the device. Nobody can take it back. Nobody can find it and say, oh, because it's A1C3PO, then it means David. Nobody could do that. But if you take away what's on the device and you bring it back to the server and you use the same hash function again and you'll compare, they will be the same thing. And then you say, oh, the password still works. But that's why hash function. Now, you can use hash functions in the service of encryption, but it is not an encryption. One-way conversion to represent a string. Now, in these, there are hierarchies. Now, SHA-2 or 256 is better than MD5. I'm not trying, you don't have to remember that. Now, how did someone determine that this making of text into something else is better than this? Very simple. Because there is, in computer science, there is no true random. It is pseudo-random at best, at least mathematically. The problem is that hash functions are not what is called a one-to-one value, meaning that if you hash 1 billion pieces of text, let's say 4 of them will create a hash that is the same. So I'm going to give it another example. Let's say you hash 2 strings that are absolutely not the same, but because of the rules of the hash function, the hashed manifestation of the string is the same, because the random is not the same. And that's exactly what happened with MD5. MD5 had a secure random. It started with a seed and the string, and then it ran XOL on it, which is a logical function. What happened is that I don't remember the ratio, but 1 every 10,000 strings were the same. And that's not good, because 1 out of every 10,000 in this world is nothing. SHA-256 is 1 out of every 1 billion. So it's over 100. So the chance of collision is that much lower, and that's why it's a better hash function. That's basically it. Now, encryption cipher is also different. There is advanced encryption system, which is symmetric. It's not public-private. However, even if you have the key and you have the encrypted string, without the exact algorithm and seed in your disposal, it will still take you days of computing power to crack what is encrypted with AES. So it's good enough to be symmetric, even though it's more hazardous. DSA is a lot simpler. It's also why AES is only supported as of API level 21, and DSA was supported as of API level, I think, 13, but it could be wrong. So DSA actually takes a hash function and then operates XO on it with a secure random. Usually, the hash function was also base64 or ND5, which is not as secure to begin with. So DSA is a lot faster to run, but it's also a lot faster to crack. So examples. Let's give a few more examples of code from how to use the Android key store provider provided with Jetpack. So if you want to generate a private key for your app to use, it will still be saved in the Android key store, but it's yours, and you can access it with the alias and the fact that you are yourself. So it is very easy. There's a generator, you get an instance, and you say exactly which algorithm you want to use. In this case, they use EC, which is cyclical. And then you say, okay, I'm going to call it alias, and I want it to be used on, for signing something like a document and to verify that that document is legitimate. I want to use the encryption, the hash function of SHA-256 for signing it, and SHA-512 for verification. Why? Because verification is brute force. You want it to be more difficult. You want someone, if they want to try and verify something, it's the first step to cracking it. So you want to use a far bigger key in order to make that happen. And then you generate it. Fairly straightforward, but you can also add even more. You could say that you can only permit the usage of your private key if the user themselves authenticated ever in your application using either a username, password, or biometrics and stuff. And you can also add in the last X minutes, because if someone left their device and it's not being automatically locked, someone can steal it, someone can do something, so you can even do better. I would only go there if you actually have PII, personal information or financial information on the device, which I would not recommend in doing ever. But if you have to, or if your product is a financial product, like a wallet or something, this is what you do. So how do you sign data with the private key? Again, these are examples to try and show, you know, for it to be clear of what I'm going to do next. It's very technical. It's not, there's no real insights here. So you get instance of the key store on the device, and because you're calling it with the developer key, so the application knows what it does. And then you get entry by alias, you get your key. And then you're saying, if it's not a private key, because something went wrong, then you have a problem and do something. But if it is, you want to get the public key. Even if you want to get it hashed. Because if someone hacks and listens to your process, you still don't want them to have a signature, so you want to get a hashed version of the key for which you can use an update and sign data. That is kind of complex. That's why I'm looking at you like that. Okay, it will be clearer as I go along, but if you have questions or if you want me to try again. Okay. Verification of data is very similar because it has exactly the same thing. I'm getting the same key in the same way, but at the end of it, I'm verifying data based on the hash signature that I get to get the certificate the public version of the key. To understand that, again, if I have a hash signature and I'm verifying encrypted information, at the end of it, it's like multiplication. If you divide something by the stuff that you multiplied to begin with, you will get the other multiplier. So in this case, to know that what you got is was signed by you, you have the hashed private, you have the encrypted information, and at the end of it, if the certificate is what you have, the public certificate, then you know that it matches. That's why it's verification. Now, similar implementation, but for legacy purposes, is in the Jetpack rather than the new Android implementation. So you can use either or. I urge you to always use Jetpack, because why use two different sets, and Jetpack keeps updating while the system does not necessarily. But I'm showing both. So in this case, the master key generation for your application, which is similar to the private key generation that was done before, is done similarly, saying I want my key to be AES 256, but I want GCM is a way for you to create blocks from the key, so you'll get 4 bits at a time, so that way the encryption and decryption are faster. But again, this is only supported from API level 23, so depending on who you use. You get a get or create. Get or create means if this application was installed right now, then you're creating a private key for the first time. If not, by the alias, because you generated the same parameters, you get the alias for you to use to call in the Android key store. And with it, you can read files which look, now in this part of the code, you don't see the actual usage of encryption. There's a reason for it. I want you to understand and see how similar it is to actually reading a file on Android. It's the same thing. You have a file input, then you have input stream. You open the input stream, and as long as you have bytes running, you read it. And then you do a byte array, and you close it. If you want to write, same thing, very similar to write. Absolutely nothing different from regular reading and writing of files. You open a file stream, and you input everything that you have in the byte array until it ends. So what's the difference? This is the piece of code before the read and write that we've done before. That's the only difference. Everything else is exactly like you did up until now. It's not different. And in here, you simply access the key. You're saying, this is the file I want to read or write. And the byte stream is exactly the same, but the file is an encrypted file because it's being built with encrypt file.builder instead of file.builder. And to do that, you create the file you want to write just like a normal file, and then you add master key alias, what key should I have access to and I want to use, and what's the encryption scheme that I want to use for the stream. That's why here GCM is very important. It says GCM split it into 4K groups. So I can read it in 4K at a time so that the stream will be seamless. You could also, it depends on the device, it depends on what you want to do. You can also do without it and get it in bulk, depends on your usage. Build. Last and probably most useful of the examples is encrypted shared preferences, because shared preferences are a great way to save data in your application. The problem is that anyone can see shared preferences if you do not have the right configurations. But here, that eliminates the need for all of them because you'll have encrypted ones. Again, same thing. You simply add encrypted before shared preferences to build it exactly the same way, create with a file name, put in the alias, and the encryption that you want to read and write for the key and for the value. And then you can save if you have one username password and you want to save it in the application sandbox, it will still be encrypted with AES 256. You can save whatever it is that you want to. Why do they have these 6 ways to do exactly the same thing? Not 100% sure. The shared preferences I do understand because it's a smaller usage of files if you don't want a full-blown file, which is big and it's hard to manage. Shared preferences make more sense for a lot of stuff. Why 2 different ways to access and verify files? Google does a lot of stuff. So I don't have a real answer, but I wanted you to know all of them because some of the tutorials talk about this and some of the tutorials talk about that, and the documentation is not in sync completely. So let's go to protecting your assets. We talked about communication, we talked about encryption. Encryption is very useful here. And we're going to start with the tools for reverse engineers, how they open up your application to try and do stuff. It's very, very, very light. Reverse engineering is either extracting the APK code assets or business logic, and is used for copying anything from the screen of the app or business logic or anything else. So there's a static analysis tools that most of you know. They've been around for years to take away the code and the XML resources and the images and a bunch of stuff. There's the older ones like APK tool and Smalley back, and there's the new ones that even cost money and do the work for reverse engineers to be that much easier. Now you're asking, why is it legal for have these tools do the work of a reverse engineer hacker? The reason that the companies say it's because it's used for cyber research. I don't have the data for it, but I'm pretty sure that's wrong. But it is what it is. But you should know that the tools are getting better, so you need to protect yourselves. There are also tools for network analysis, for them to try and understand your server-client communications and their client to third-party server communication for them to steal stuff, like API calls and the way that your objects are organized to understand how their data is being run. And here you also have a set of tools from running on a rooted device, so you'll see everything to Wireshark that do basic sniffing, where they're not connected to a specific device, but they can run on anything on the network. So let's start with code. How would you protect code? And we're starting the concept of obfuscation, and I'm going to start real slow. This is a very stupid example. I have a key, I have the value, I'm using this class to encrypt key value. Any moron can understand exactly what I'm doing and what's the value for anything. So if someone was to reverse engineer this masterpiece, they would see exactly what I'm doing and will take away exactly what I need. So, as we said, value, key, encrypt. Reflection that we talked about earlier is a way for you to not actually have access in scope to objects, but getting them through the binder system of Android. It was used in a bunch of stuff low level in Android, and it created a semi-backdoor that Google is fixing bit by bit, but not completely. But it could be used in your defense, because you can do that. You can change this into this. Now, these are exactly the same. It's the value and the key. But instead of calling the class crypto engine and the method encrypt, you're calling class by name, and then inside that class, you're calling method by name, and then you're invoking this from that with these. Still, when someone looks at that piece of fairly simple code, they can understand exactly what's happening, but that's another step in the way. Next, you can say, this tells me what this is. This tells me that this is a key. This still tells me everything, so let's just lose all of it And instead, hey, that's not, oh yeah, string obfuscation. So I was explaining the wrong thing. Doesn't matter. So instead of me knowing exactly that this is a crypto engine and I'm using encrypt, I'm actually using these. So ABC123 is not ABC123, it's and a secret key is something that's nobody can read. The name of the class is something that nobody can read. The name of, and in all of these, I'm using base64 because it's a very old example that I had, but you can use any hash function you want to. You can even use encryption for that if you really want to. But it's just an example to explain a principle. And at the end of it, you have something that's very hard to read. And yet still the variables tell you pretty much what I want to do. So the last thing, the easiest thing, is to actually change the names of the classes and methods. So this could be anything. Now, I'm not suggesting that you'll do all of this manually, because in this example, it's very straightforward and understandable, but I'm trying to lead you through what you could do. And there's a pretty nifty little tool to do that that's been around for ages. Anybody can guess what that is? ProGuard, there you go. Unified also, same thing. ProGuard, very, very easy to use. How many people here use ProGuard in any extent? That's good, but that's still a third of the people. So I'm glad I brought it up. Minify enabled, this is a configuration, Gradle configuration of ProGuard. And basically you have the stencil. So Minify enable basically said that any unused code is wiped out. So a smaller APK, not security, but still cool. Shrink resources, any unused items in resources to be removed. Again, not security, but cool. This is adding all of the rules for various stuff that are pretty self-explainable. If you're using HTTP, Mixpanel, blah, 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 you can use anything you want. You can write your own, doesn't matter. And then debuggable false, blah, blah, blah. Fairly straightforward. Now let's go to the interesting ones that are not here, that are security related. Flatten package hierarchy. Sounds interesting. What does it do? It repackages and renames all the package into one parent package, including all the class names, all the method names, everything. But you also have one, it sounds very similar, repackage classes. Why is that there? And the first line is exactly the same. It's very strange. But in this situation, it does not only moves all the files into one file and then renames everything, it also removes all of the other folders. So you only have one folder full of A, B, C, D, 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 H something. Why would you need both? So the reason you don't need both. This trumps that, but in some cases you cannot use that, because if your code is looking for resources specifically, classes for resource files in their packages, then if you run this and not that, then it'll fail. It will crash in runtime. So try to use this, and if it crashes, try to use that, or try and understand if the usage for local resources is acceptable. Maybe you can remove that, because if you only have one folder of nothing, it will still be better and harder to understand if someone tries to reopen the package. Last thing is allow access modification, saying that automatically, if I did something that doesn't make sense because of the obfuscation, meaning that if some of the getters that I did, I said that they were private because they were in the same package, but now everything is in the same package, but it not really is, then it changes the modifiers automatically. So if you had an inlining of a public getter, then it changes it to private and makes it more secure. The problem is if you're trying to create a library for other pieces of the application to use, that's not good, because then it's private and then it doesn't have access to it. So again, try it, see if it crashes, and if it does, try and see if the reason that it crashes is something that you find acceptable. At the end of it, you'll have this gibberish, which for you, I don't care, but if a reverse engineer looks at that, it's harder. Now, it all depends on the size of the prize. Most of the not most, let me see, I don't remember the exact statistics, but it was over 70% of copied applications used no protection. Reverse engineers are lazy people. They're engineers that choose to steal from other engineers. Now, engineers in general are lazy, I know because I am, but it takes a special breed of engineer to be this lazy to not create something but steal something else. So if you present even the slightest hurdle, you might be safe, and it's free. So I really urge you to use that. Let's go on to network. Sniffing is a term that I specifically love. I just like saying sniffing, it doesn't make any sense. Is that either on the device or on the router, they're trying to see the network communication out of the device or out of your application for benefit of some sort. A more advanced method is man in the middle, is saying, I do not only care about the communication, I want to see if I can con you. So they will create something called a plugin where your application on the device will communicate not with the network, but with their application. It's usually done on a rooted phone, but still. And then with the payload that they give you, they will try to communicate with the server, get the answer, and play like a middleman. Why would you do that? Because if you do that, you get far more access and you can try new workflows that the application does not necessarily have. So one such attack that here's an example to it on a very, very, very popular application was used man in the middle. Again, it was a service company, like a delivery company. So what they did is that they tried to see the demand from clients that are calling the service, but instead of using it to disseminate to the other applications, they used it to offer it in their service. I'm going to give a better example. That was a terrible example. Let's say it's a taxi company. So the taxi drivers get these calls saying these people are waiting here for you to pick them up and go somewhere else. They're getting it from the application. But if I had access to the bidding system and I have the information, and then I call the drivers with a different app and saying, same database, because I didn't work to get it, I'm getting it directly from the original application, but I'm going to give you more money if you choose through me and not through the first app. It's basically man in the middle. They're using their resources. It's what I call piggybacking at the beginning. It's very similar. I'm going to use their resources for my benefit. And because I'm in the middle, I get fresh data all the time. Because when one job goes away, another comes in. Now, this is using a MITM proxy, man-in-the-middle proxy. This is on a rooted, it's installed on the phone, it's on a rooted phone, but notice that this is HTTPS. SSL is supposed to be super secure, right? And yet, you're seeing exactly what query it is, and you're seeing exactly what the payload is. And that's certificate secure. That's because it's very hard for you to control where your application ends up in. So you're saying, so I'm not saying that SSL is not good. I'm just saying that you need extra step if you're a big enough target. That said, I mean, if your information, it depends how precious that information is, how big is the competition. So using SSL is still a good idea. And I'm going to stop a little bit to talk a little bit more about SSL. Okay. Okay. I'm going to run real quick. SSL encrypts HTTP communications client and server. Now,
Maybe it's time to have a break.
oh,
We have.
do you want a break?
Yes, we have a.
So that was
Android
the.
by Sim.
I'm terrible in getting signals. My wife will be the first person to tell you. Sorry. So have a coffee break. I need coffee as well. There you go. Okay, so we're back. I started by hammering on SSL because SSL does not actually do anything specifically if the hacker has access to a device where your application is installed. But SSL in general is a good concept. And that concept is that it encrypts HTTP communication is basically text. You're throwing away text from here to there, information to your application. SSL encrypts that text by using public-private keys or certificates with public-private keys. So a server is identified with a certificate known as a CA. I'm not going to explain it that way. It's almost impossible to understand. So remember Bob Alice and not Alice? So you remember this screen? Say, hey, an encrypted message from Bob. I'll try Alice's public key. No. So let's assume that not Alice had a gender reassignment surgery, so they don't speak that way anymore. And they're saying, okay, luckily I stole Alice's private key. I have it with me, so I can encrypt wherever I want to, which is the equivalent of you obtaining a legal-looking certificate from a website. But when they try to use it, they don't get service. Why? Because in the situation where a certificate, unlike a private-public key where they are only private-public key, a certificate is where you have a public-private key, but they are associated with a specific instance. With certificates, it's a website, but in this example, I'm trying to say, oh, it's not registered to my computer, so they know that I'm using a key that's not mine, and therefore they're capturing me. It's not a great example, but I think it illustrates it great. So a hacker could obtain a real-looking fake certificate because it's close enough, because they find a way to register it correctly or a bunch of other stuff. Or you could have a service, there was a good service, it had a good certificate, or it bought a good certificate, and then it went bad. It still takes a while for a certificate authority to understand that a service went rogue and to revoke permission access. So that could also be a reason. So what do? You could create your own SSL certificates and only use them. You could do that. But that is massively complex. You have to manage revoking rights and updating. And if the certificate is being revoked because it's past maturity, then you need to update the entire application on all the devices, or those who did not update get a denial of service. It's a lot of work for something that could be solved a lot easier, and that's SSL pinning. What SSL pinning means is that it's, instead of me saying something like, everybody that has a correct SSL certificate is okay, I will say something different. I will say, I know specifically who am I working with? What is an acceptable entity for me to talk to? And I will list those services specifically. Because if you're working with your server, you know you're working with your server. Pin their certificate, only talk to this guy. If you're working with Google Analytics, they have a specific certificates. Working with that. Not everybody that has a legitimate looking certificate is trustworthy. So how do you do that? How do you do a pinning? You identify, for you to pin a service, you need the host name, which you should have because it's a URL you're approaching. Let's take an example, GitHub. I know none of you will approach GitHub in your application, but it's a viable example. And you need the public key hash from the host. And no, I'm not kidding. You can get that because it's public. They release it. It doesn't mean anything unless for identification. So there's a website, sslabs.com. What they do is that they hold the public keys with the host name of all the services that you're using. And if you go on that website and you look for API github.com, next to it you'll get a hash, a 256 character pile of something that you can copy, and then you open up this file and you do HTTP builder, okay, HTTP just like you normally do, but then you add new certificate pinner. In this connection, I only want to talk to API github.com and the hashed certificate. Only this, only if they identify with this certificate. Everything else is the same. So when you will approach the base URL of API github.com, if they have a certificate whose hash is not this, then you know someone is trying to bullshit you. You know it's a man in the middle. You know it's a sniffing attack. You know it's a service gone wrong. You know it's something. If someone approaches you outside of API github.com, no answer. Again, because it's someone's trying to spoof you. And unlike, there's in phishing, do you know what phishing is? Phishing is the way that you are sent into a website either through email or something that seems like one thing, but it's actually something else. So the human eye is not that good. Because if you get a URL that looks like API github.com, but this dot is not really a dot, but a Spanish question mark or something that looks like a dot, to the human eye, it looks exactly the same, but it's not the same Unicode. To you, it looks exactly the same, but for certificates, it does not. So it will work better. And that way, the chance of you being, because even a man in the middle attack on the phone will have to impersonate something else. Most of them cannot replicate the host name and certificate in real time. It's very hard to do. It's not impossible. If someone is bored enough, they can do it, but it will take an enormous amount of effort to actually do that. So that was the first thing I'm going to say do. The second thing, because that precludes men in the middle, it does not necessarily preclude sniffing. For them to see your communication, to see your objects, to copy them or do anything else. So for that, I would recommend something like Wire. Wire is, instead of using human-readable text like XML or JSON, they're using binary streams that don't mean anything. So even if they see a binary stream, their ability to decompile it into something that's readable is non-existent. It looks something like that. There's like a replacement algorithm and a bunch of other stuff. So it's safer in that effect. And the performance is a lot better because the record size for JSON is fairly large because it's human readable. In byte streams, it's a lot smaller, therefore more performance, not security, but still nice to know. The problem is that my personal favorite of getting a bug and then opening up the API and seeing exactly that it's the server guy's fault and just reassigning it, which was my hobby for years, it's a little bit more difficult. Again, not impossible because you can do both. You can basically just retrofit very easily. You can do both. So it's a fallback. If you see Wire, because you're getting Wire from the server, you use Wire. And if you get JSON, you get JSON. So you can, like a production server will use Wire, but a test server will use JSON. So you can test the API and still throw bugs at the server guy or girl. So I keep on doing it. I did all this work to do line by line, and then I explain everything. So again, base URL in retrofit, you build the client builder, then you add Wire, which is, if you have it, take it. If you don't have it, then you probably have JSON. If you don't have both, then you have bigger problems anyway. And build it. Now, I was asked a bunch of times in the intermission and before that, let's assume someone still finds a way to hack or to obtain the APK. How do I create a denial of service anyway. So there's a way to do that. There's a way for you, if you can identify that the instance running on the device is yours and legitimate in real time, you will service it, and if it's not, you will not, right? That sounds simple. Now you're saying, how would I do that? How would I change the instance running on the device in real time without updating it? Well, there's a bunch of ways to do that, but there are also ways to verify if the instance is from a legitimate source or not. So, there is a way for you, during a handshake with the server, to ask, as part of your code, the application, what is its signature? Its signature, it's the hashed, it's its hashed value of the checksum value of the code in the app. And because you know what is the checksum of the app, because you have the original APK, you can compare it. The problem is that a hacker can do that as well, but we'll get to that. So you compare it with known version. So this is how you get from the package manager, you get the signatures, and then you get from all the signatures, you go through, you get the instance. In this example, I choose Shab, it could be anything. And then you go signature by signature, and you encode it back to strings, and you see if the signature matches to what you know from the server. And if it's valid, that's good. You can also use Google to make sure that the device is not rooted and the application was downloaded from Google Play, which is nice, but it's not everything. Now, I didn't think we were going to have time for this, but we do. So I don't have a slideware for that, but I am going to entertain the concept of what happens if the hacker is smart and diligent enough to know to take the APK checksum in runtime and intercept your comparison here. Okay? So there is a method for you to upload, to download a library in runtime and install it as part of the APK in runtime. Trust me, there is. Google it. When you do that in runtime, you basically change the checksum of the application. So when you will do this, the checksum will be of the complete running file. The APK that you know that's static, but also the library. Now comes the interesting part. If you, by handshake, by instance, provide a different library out of a repository of 50 libraries, you will give a library that's being downloaded. It is being uploaded. The checksum of the running application is different every time because it's the, I don't remember the statistics arithmetic here, but it's not 1 out of 50. It's like 1 out of 1,000,000. The possibility for the hacker in real time to identify the library, because to deduce the library size and the compared size and to run a checksum in real time, almost impossible. Not impossible, almost impossible. So by simply doing that, simply downloading a piece of code that's different in value and it's randomized based on the handshake, meaning that every instance get a random version of it, you reduce the possibility of a man-in-the-middle attack in real time to close to 0. Now you can add to that. You can basically say that the library that you're loading is not just dumb code for you to change the checksum. It could have logic to it. And that logic is only known to you because only you know what you downloaded. So you can ask for the application outside of the checksum. You can ask, what is the solution to the problem I just gave you? That adds a second layer of complication. You can, there are multiple levels for you to do. The whole point is for you to introduce entropy into the system, to do something that you know, but the hacker has no way of knowing because it's not in a static file that they can have for days. Because that's the problem with the APKs. If you have a hacker, they can sit on your application, reverse engineer it, run it on their device, see everything, and then the whole point is for them to impersonate you as a man in the middle. if you introduce something in real time that's different every time, or different 99.5% of the times, it'll make it almost impossible for them to do what they're doing. Cool? So, I have reached the end sooner than I was supposed to, and I'm gonna do a quick summary of everything that we went through in the last 2 hours and change, which is, it is very important for you to consider protecting your code with obfuscation and runtime verification. It is also very important to protect your API with obfuscation and runtime verification. Protecting users' data and your data using the right tools and permissions and the right communication patterns, just like a conversation I had with one of the developers that asked regarding a hacker. There's probably an issue there that's an open door that allows that hacker to do whatever they want with their activities, is very, very important. So tools and patterns that are free, that are available in documentation, although not very good documentation, but they are available, is important. And encryption of sensitive, private, or financial data is not only key, it's possible, it exists, although backward compatibility is terrible. So it all depends on what it is that you can do, but technically you can run encryption that's decent all the way to API level 1. It will simply take more of your time and effort. And the first thing we talked about, which is very important but not necessarily related to privacy and security, is that you should really think about the use case that your users is facing. And you should try your best to tailor yourself to their situation and gain their trust using transparency and consistency. But that's true for any situation, any user experience, anywhere. Questions? Yeah.
Thank you. So again, my name is Arthur, and my question will be about key stores, Android key stores. Usually we have some debug key store and the production one. And sometimes we want to check if the app updates well, so we want to check, we want to be able to sign it with the same production key store. And let's say that we want different people, different developers, to be able to create this build signed by basically production key store, right? The bad solution probably would be to just give this production key store to everyone, logins and passwords and all of this stuff. However, do you know any way to do it, for example, maybe on CI server, that let's say that we want any build that we create to be updatable to another one, to like facilitate debugging and all of this stuff. And for this, we need to have this key store on CI, or we need to have some way to sign a build using production key store and production key on CI. Do you know any way how to securely do this?
Unfortunately not. Sorry, it doesn't mean that it doesn't exist, but it does mean that I do not know of such a solution.
Okay, yeah, but if we will at least like think about what are the complexities there. So yeah, can you try like a little bit discussing what could be the option and what is the downside of it?
So the moment that you introduce the production key store in the build, the risk is not, let's try something different. What's the benefit? What's the benefit of you signing something with production key store when it's not a production version?
Yes, maybe we can get a little bit longer. I mean, the final goal is to have this like one button rollout, one button release. That's like the perfect world. When I have, for example, my staging on master branch, I think that, okay, it's ready, I press a button, this build goes to Play Store basically, maybe with some additional check just in case.
Oh.
Even to do this, we already need to have this production key store somewhere. And if we do already have this thing, then probably it's logical that when every developer creates like a build, we could theoretically get the build signed with the same key store just because we can.
Right.
Yes.
Okay, so I might have not understood your question. You absolutely can create a production signed version based on CI. I know a bunch of teams are using Circle CI to do that, no real problem. So I might have not really understood your question.
Yes, the question is how, okay, we don't have this yet. And the question then is how to do it in a secure manner. To basically, because we will need to have our key store and some key and passwords basically on CI, maybe like in some environment variables and all of this stuff. However, that's,
so it's more of a DevOps question. And I happen, look, what's the name? Not Hiroko, not Hish, something. There's a product called Vault. I forgot the name of the company. It's very, very, very big. Basically what you do is you install an HSM. HSM is a piece of hardware that is air-gapped and can only be accessible through inside your CI system through a very specific protocol. It sometimes involved physical keys. What's the name? Hiroko, Hirosha, HashiCorp Vault. Now, the integration and DevOps around it is fairly complex. It's unbelievably complex. You have to buy the HSM. You have to. They have an open source version, but it takes good SecOps weeks to integrate it into a CI system. But once it's done, it's probably the most secure system you'll have ever. There are newer generations of these kinds of solutions that use a protocol called MPC, a multi-party computation, which is a derivative of cryptography that's similar to blockchain, but not necessarily the case. That's where nobody really has a key. They have fragments of the key that they are not recompiled back to the same key in any way, unless within what is called is the secure runtime within either your mobile or your server. Most of these solutions, no, I do not know any solution in the newer generation that's production ready. There are multiple startups in various stages that I know that are gearing up to releasing such a solution in the next years.
Thanks. So for now, like the best solution is just to have 1-2 people who have this access to production key store and who can basically sign it, run the signing.
Yes, but if the target that you're representing is a lucrative one, like the access to that key can cause damage that is a lot of money, I would seriously suggest that you look into HashiCorp.
Thank you.
Hi, thank you for the talk. How about the situation where we have a dependency on some library and new version of this library became somehow harmful for our application or user? How can we detect this problem? Is there a way?
So the first thing that pops into mind, and I'm super biased, okay? It's a portfolio company that was acquired. It's called SafetyK. That's basically what they do, okay? But I'm, again, super biased. I invested in the company. So leave that aside. There are services and sites known as cyber intelligence. Those sites are like, when you have cyber offensive companies, companies that are making their money out of protecting a bunch of stuff, part of their money goes to researchers who try to do these kind of stuff. And when they find something, they publish it right away because that's their claim to fame. We have a bunch of portfolio companies whose claim to fame is we were the first to discover WannaCry, or we were the first to... So you have these companies that are called cyber intelligence. It's their job to notify you saying, look, I know that you use 1, 2, or 3. it's dangerous, this is an attack that impacts this, change it right away. That's their job. Now, again, depending on how much money you make and how big of a target you are, you could use any of these services. Some of them are actually not that expensive. Or you can simply subscribe to multiple sites like this and create your own script of saying, you have a list of your libraries, they have a package name. Most of these alerts are by package name and by version number. So you simple search every day to week of the vulnerabilities will give you a lot of intelligence. It will cost nothing because these databases are public. The problem with libraries, it's very hard to know how susceptible you actually are. Most of them rely on a lot of reputation, and the one thing that I love about the open source ecosystem is that it's very unforgiving. If any of you have ever donated code to an open source project, there are some massive jerks out there. Like, they will pick your code apart, and that's a good thing. That's exactly why open source works. And as someone who contributed code back in 2008 to the open source project that later became Android, oh my God, we needed more jerks, because if my code got in, that is terrible. And that's exactly why I trust open source, but mistakes still happen. So cyber intelligence is usually the key there.
Thank you.
Sure.
Yes, hello again. Thank you for your speech. My name is Dimitri. And the question is about, it's more practical. In case if we are communicating with API service, I mean with our backend, and we have a P key, which we have to use to connect.
Mm-hmm.
So am I understand right that we couldn't really decrypt it because when we connect to the API, we need it in a like the string, the original string. It cannot be decrypted. So it means if somebody would reverse our APK, he would see that the key is the original key, and he could steal it. Am I correct? And what would be the way to protect?
That is exactly, first of all, it's a very good question. It's a very good practical question, because that is the exact explanation of the difference between hashing and encryption. You cannot hash the API key because you need it in text, but you could encrypt it. If you encrypt it in shared preferences and you decrypt it to send it in the SSL, then you're protected on the device. You are not protected when using the SSL itself, as I showed later on, against a man-in-the-middle attack with the third-party service. So usage of API keys like I think that the question here is the identification, because in a lot of cases, a lot of new APIs do not ask you to put the API key as part of the actual link, but as part of the payload. That's the desired approach, because a payload could be encrypted as part of SSL while the URL itself cannot be. Still not 100% secure. If someone is using MITM proxy, they'll see it. So if that service that you are using is worth a lot of money to you, my suggestion for you would be something that is not a really good pattern for mobile development, but it is more secure. It is that you were to send authorization to your server to identify for you for that service and provide you with a response using wire. Now that is more complex, it's annoying, it has a performance gap because you're doing like this instead of one time. But if that service is valuable, that's the way to go. Either that or approach them, that API key, and ask them to support bytestream streaming like Wire. And it might happen because it's not that big of a job.
All right. So, and in that case, you mean that anyway we need the support from a backend team. Like we cannot protect ourselves just from our side.
Again, if you encrypt using encrypted shared preferences, you are protected against a lot of attacks. The only attack you're not protected against is if someone roots a phone, takes your APK, installs on the APK with a MITM proxy, and listens to your API to find that specific SDK. That's a lot of work. So it really depends how valuable you think your app is and that service is. If it's super valuable, could happen. Unlikely though.
Okay, thank you so much. Got it.
Sure.
Yep, I have kind of a comment here. Previously you told that, for example, MD5 or other hashing mechanism, it can be used if we don't want to basically decrypt the message back. However, because of this, people might think that it's kind of safe to do this. And I think that you can add a remark about, for example, hashing phone numbers, that if you hashed like a phone number, it's pretty easy to get it back. Just because amount of basically collisions and just a brute forcing.
So you're not getting it back. You're simply making a mistake, because if you're hashing two phone numbers that are different, but their hashed value is the same, you have no idea who's who.
Right, but I mean, overall, if we, for example, think that, oh, okay, I'll hash this phone number, and if like attacker will have this hashed basically string, they will not understand what was that phone number. And I mean, in many cases, having like 2, 3, 5, 10, maybe even numbers for the same hash is not a big deal for an attacker.
And that's exactly why MD5 is not that secure.
Right. So I just wanted to.
No, it's a good comment.
Highlight this. Yeah,
it's a good comment. If it's something that's super private, prefer SHA-256 or 512. Definitely on MD5, and definitely on base64. Base64 is definitely for XOR actions.
Okay, yeah. And a question that I have, give me a second. Okay, I think I'll ask it next time.
Oh, you can find me on Facebook.
Okay.
You do it again. Cool. So.
No more questions.
No more questions. This, I always finish my presentations with this. It's completely irrelevant, but it's I find it uplifting. This is Larry Page, one of the founders at Google. And this photo was not taken by me. You can see because it's Mashables, but I was there in the audience. It was Google I/O 2013. Yes, I am old. So Mr. Page went on stage, and I didn't recognize him because I was far away. And I don't know if you've heard him talk in 2013. He sounded like Kermit the Frog. He really sounded terrible. And we started making fun of him because he sounded something like this. After that, we felt terrible because we understood that he sounded like this because he had throat cancer, which makes me an awful human being, but that's irrelevant to the story. My point is that as uncharismatic as his voice was, by the end of what he said, we were super pumped because he said something that is true. He said something along the lines that in this room, I'm stating him, I'm talking to you, but he talked to us. In this room, there's a sea of innovators. Basically, the biggest advancements of innovation that this world has yet, that will change the economy and the way that we approach things in this world has not yet been created in our lifetimes. These things will be created by people of vision and action, people of development, people like me and you. So go out there and change history.
So I switched to Russian. Sorry. Ребят, это последняя лекция Академии нашей в Авито, вот нашего текущей Академии Advanced. Надеемся еще в будущем вернуться. Давайте поблагодарим ребят за пироги, за то, что они нас захостили и за отличный прием. Далее мы вам скинем форму для обратной связи. Надеемся, то, что вы запомните, потому что для нас очень важен ваш фидбэк, чтобы стать лучше. Соответственно, слайды будут выложены чуть позже, как и лекция на видео, чтобы все еще раз посмотреть, осознать и так далее.